Hi guys, let's look at the next question. The next question is question number 1, part 3. So again, the left hand side is more complicated. I start with left hand side and I convert tan into sine and cos. So this becomes sine A upon cos A, everything divided by 1 minus cos A upon sine A, plus this becomes cos A upon sine A, everything divided by 1 minus sine A upon cos A. Let's take LCM. So this becomes sine A upon cos A, everything divided by sine A minus cos A upon sine A, plus cos A upon sine A, everything divided by, take LCM and subtract, this will become cos A minus sine A upon cos A. So this is division of fractions, so let me just convert this into multiplication. So this would become sine A times sine A upon cos A times sine A minus cos A, correct? Plus this becomes cos A times cos A upon sine A times cos A minus sine A. Done. Let's see if I can do something now. Well, I have the option of changing sine square into 1 minus cos square, but I don't think it is helping me anyhow. So let me just see if I can take LCM. Before taking LCM, I realize this is sine A minus cos A and this is cos A minus sine A. So like in the previous video, I can change the sign by changing, so I can convert this into sine A minus cos A by taking a negative sign outside. So let's just do that. This would become sine square A upon cos A times sine A minus cos A, and I change the sign here. So this becomes minus and this becomes cos square A upon sine A times sine A minus cos A. Perfect. Now my denominator for both these terms is equal, so the LCM is the same. Now let's just, no, the LCM is not the same. This term is equal to this term, so my LCM now would be cos A dot sine A minus cos A. Perfect. It will just basically be the multiplication of these three terms. So my numerator now becomes, this will have to be multiplied with sine A. So this becomes sine cube A and this becomes cos cube, cos not square, cos cube A. Done. Now this is in the form a cube minus b cube or x cube minus y cube, which means I can write this as x minus y into x square plus xy plus y square. So let's just write this. This will be sine A minus cos A times sine square A plus sine A dot cos A plus cos square A, and the denominator remains cos A dot sine A times sine A minus cos A. I'll have to write the reason. This and this gets cancelled. The reason being, since x cube minus y cube is equal to x minus y times x square plus xy plus y square. Done. Yes, that's the reason. And now I am left with, in the numerator, sine square A plus cos square A plus sine A dot cos A, and in the denominator I have sine A dot cos A. Now sine square A plus cos square A is nothing but 1. So the numerator is 1 plus sine A dot cos A upon sine A dot cos A. Now the reason for this is, since sine square A plus cos square A is equal to 1. Now we will divide this and write it into separate terms. So this would become 1 upon sin A dot cos A plus sin A dot cos A upon sin A dot cos A. This and this gets cancelled. So this is nothing but 1 upon sin A into 1 upon cos A, which is nothing but cosec A dot sec A plus 1, which is equal to the right hand side. So hence proof. This is exactly what they wanted us to do. Look at this question again, a very interesting question. We started with converting tan, cot to sine and cos. After doing that, we realized if I change the sign here and if I convert this plus into minus, this part and this part would become equal, which would make our life easier. And after that we just added, and then we used x cube minus y cube formula, and that's what helped us to get into this final answer. Good. Let's look at the next question. The next question that we do is question number 1 part 5. Question number 1 part 5 is 2 sine square A plus cos to the power 4A is equal to 1 plus sine to the power 4A. Let's start with left hand side. I notice that on the right hand side I have only sine, which means I have to remove this cos somehow. So, but I don't have any relation between sine and cos with the power 4. The only relationship is when the power is 2. So let me write this in the form of cos square A square. Let's try if it helps. So this would be 2 sine square A plus cos square A whole square. That's my left hand side. And now I have 2 sine square A plus, instead of cos square A, I can write 1 minus sine square A. Why? Because I know on the right hand side I only want sine, so I have to remove this cos. So this would become 1 minus sine square A the whole square. Reason would be since cos square A is equal to 1 minus sine square A. Done. Now 2 sine square A plus, now let's just open this bracket. This is in the form x minus y whole square, which means x square, in this case 1, y square, in this case sine to the power 4a, minus 2xy, minus 2 into 1 into sine square a, so minus 2 sine square a, plus 2 sine square a, and minus 2 sine square a gets cancelled, so I'm left with 1 plus sine to the power 4a. Done. And this is my right hand side, so I have reached where I needed to, hence proved. Done. Simple question. All we needed to realize was how to convert cos to sine. Good. Let's look at the next question. The next question that we do would be question number 1 part 7. Let's look at question number 1 part 7. It says cosec minus sine into sec minus cos is equal to 1 plus 1 upon tan plus cot. So let's start working with the left hand side. Looks more difficult to me or more complicated to me. So let's start. So left hand side would be, well, I will convert everything into sine and cos because there are too many relationships here. Sine, cosec, sec, cos, too many relations. So let me just convert everything into sine and cos. So this would become 1 upon sine A minus sine A, and this would be 1 upon cos A minus cos A. The reason being, since cosec A is equal to 1 upon sine A and sec A is equal to 1 upon cos A. Now, so that's the reason why I moved into this step. Let's move on and see how will it help us. Now I take the LCM and I add. So this would become 1 minus sine square A upon sine A multiplied with 1 minus cos square A upon cos A. Good. So let's see if I can get something from here. I know that 1 minus sine square a is equal to cos square a. So this becomes cos square a upon sine a multiplied with, and 1 minus cos square is equal to sine square a. So this is sine square a upon cos a. Reason being, since 1 minus sine square a is equal to cos square a. Same reason applies for 1 minus cos square would become sine square. Perfect. So does anything get cancelled? Yes. So sine a and this power get cancelled. Cos a and this power get cancelled. So my left hand side becomes cos a dot sine a. Let's see if I can now work with the right hand side and also get it to this cos a and sine a. Let me try. Let's look at the right hand side. The right hand side is 1 upon tan plus cot. So let me convert tan into sine and cos, and cot also into sine and cos. So this would be 1 divided by sine a upon cos a plus cos a upon sine a. And the reason would be, since tan a is equal to sine a upon cos a and cot a is equal to 1 upon tan a. That's the reason. Next, let's take the LCM of the denominator. If I take the LCM, this would become sine a dot cos a, and on adding, this would become sine square a plus cos square a. Sine square a plus cos square a, which means division of fractions. So this becomes 1 multiplied with sine a dot cos a upon sine square a plus cos square a. The reason, there is no reason required here. This would become sine a dot cos a upon 1. Reason would be, since sine square a plus cos square a is equal to 1. So this is also now equal to sine a dot cos a. So since left hand side is equal to right hand side is equal to sine a dot cos a, therefore LHS is equal to RHS, hence proved. Done. So this was the question where we solved both the parts. I solved left hand side separately and I solved right hand side separately, and we got a common answer. Good. Let's move on to the last question that I'll solve from this exercise, which is question number 1, part 8. Let's look at that question. It says 1 plus tan a dot tan b whole square plus tan a minus tan b whole square is equal to sec square a dot sec square b. Good. Let's see what can I do. I can convert this into tan, or let me just open the bracket first, because then it'll give me some relations. Right now all these are in power 1. If I open the bracket, everything will become in power 2. So this is in the form x plus y whole square, which means x square plus y square. In this case, tan square a dot tan square b plus 2 into 1, that's 2, times tan a dot tan b. I opened it because I also realized when I open this will also get me the same thing, minus 2 times tan a tan b. So let's still open this bracket. This would become plus tan square a plus tan square b. This is in the form x minus y whole square. So x square plus y square minus 2 times xy. In this case, tan a dot tan b. So 2 tan a tan b and 2 tan a tan b gets cancelled. So I have 1 plus tan square a dot tan square b plus tan square a plus tan square b. I know a relation which is 1 plus tan square a, which is sec square a, and that's something which I want on the right hand side as well. So I will combine these two and I will write this as sec square a plus tan square b plus tan square a dot tan square b. The reason would be, since 1 plus tan square A is equal to sec square A. Next, I will take some common element between these two. What is common between them is tan square B. So let me just take tan square B common. What I'm left with is 1 plus tan square A, which means this would be sec square A plus tan square B into 1 plus tan square A is sec square A. Again, since 1 plus tan square A is equal to sec square A. Next, anything common between these two terms? Yes, sec square A is common. So let me just take sec square A common. What I am left with now is 1 plus tan square B. And 1 plus tan square B is nothing but sec square B. The reason being, since 1 plus tan square B is equal to sec square B. This is what I wanted in the right hand side, sec square A plus sec square B. So this is equal to right hand side, hence true. Again, a very interesting question. We use the same identity 3 times and we get the final answer. So the homework questions for you from this exercise would be question number 1, part 4, part 6 and part 9. Question number 2, 3, 4, 5, 6, 7, those kind of questions you can ignore. Those kind of questions are never asked in the board exam, but you can still try and solve them. If you have any queries, you're welcome to ask me. Thank you so much. Take care, be safe. I will put a video for those questions as well, but from the exam perspective for ICSE board, you can ignore such questions. Bye bye.